Hello friends, welcome back to the Start Pro course. Up till now we have completed the analysis of beams, and in the last video we have discussed about the analysis of single bay frame. In that we solved some problems for analysis of single bay frame, like this is one frame, then this will be the second frame. Now in today's video we are going to discuss the analysis of multi-storied frame. Now here, considering this multi-storied frame, the vertical floor to floor height is given 4 meter, 4 meter, 4 meter, and gets subjected to this horizontal and the uniformly distributed load. So in today's video we are going to discuss analysis of this frame by using the StatPro. Okay, so let's start with that. First of all, we do the modeling of this frame. Select the first plane. Now the frame number 3, length in meter, load in kilonewton. Next, add beam, finished. Okay, now let's take the front view. So here select the 4 meter, then next 4 meter. Now you can add over here the vertical height up to 12 meter, then next 12, then horizontally it will be of 5 meter. You can change the grid size up to 15, next 5, then next 5, next add the beam. Just delete these 3 beams. It will be of span. Okay, select this node cursor, delete. Yes, because the span which we are taking is 5 meter. Okay, that's why I have deleted all this. We are drawn this at a span of 4 meter. Okay, now next again. Now you can complete, or you can draw this multi-storied frame by using the translational repeat command also. You can complete one floor and then you can repeat this up to the number of upper floors by using the translational repeat command. Okay, now this will complete our multi-storied frame. Height will be of 4 meter, 4 meter, 4 meter, and the horizontal height will be of 5 meter, 5 meter, 5 meter. You can also draw this by using this translational repeat command also. Okay, now next we are going in the property. Let's define the property size or section size. Let's take the rectangular section of 0.35 by 0.35. add over here, close, then select assign to view. Now here this time we add 2 sections over here. This section, yes, 0.35, 0.35. we define one more section, 0.4, then 0.4, add, close. This 0.4 by 0.4 cross section we assign for all the horizontal members. So here we can select the beams parallel to X, and we are assigning to selected beam, assign yes. Then we are assigning this vertical section to all the vertical beams. Select the beams parallel to Y, selected to beams, assign yes. So the second cross section sizes get assigned to vertical members and first cross section sizes get assigned to horizontal members. Now next go in the support. So here in support we are creating the support of fixed support, add over here. Now here you can select this side view also. This is a front view. If I am taking this side view support, and now you can check over here all the nodes along that will be get selected. So here you can assign to selected nodes, assign, yes, right. Then next go for the loads. Here we have to add 3 horizontal loads, that is nothing but the 20 kilonewton, 15 kilonewton, 30 kilonewton. Normally whenever we are analyzing this type of multi-storied frame, you have to remember that all the loads assigned this joint of horizontal beam and column, these are nothing but the wind loads or earthquake load. All wind load and earthquake load, these are always acting horizontal forces, or you can say the lateral forces. So here we are assigning this as a 30 kilonewton, then 15 and 20. So let's complete first of all this 30, then yes, 15 and 20. So let's add here load case details, add. Now I'm not adding those loads as a wind load or horizontal load, I'm directly considering as a load case 1, add over here, close. So load case 1, or here let's take 2 load case. We analyze the beam first of all for the lateral forces and then one more as a, so you can consider here as lateral forces, okay, change, close. Then one more load case 2, the vertical forces, okay, add, close. Now in lateral forces we are adding this nodal loads in x direction 25 kilonewton, then 30 kilonewton, then 15 kilonewton, close. Then vertical load 18 kilonewton per meter and 17 kilonewton per meter. So here in vertical forces add over here a member load of minus 17 kilonewton per meter, add, then minus 18 kilonewton per meter, add over here, close. Now let's assign the loads. Fx 25 kilonewton per load, assign the selected node, select the node cursor, assign, yes. Then next 30, select the node, assign, yes. And then next 15 kilonewton per meter, select the node, select the node, assign, yes, okay. Can reduce the arrow height through this, okay. Can display the load values. So 25 kilonewton, 15 kilonewton and 30 kilonewton, okay. Now load case 2, uniformly distributed load, select the beam, (17 kilonewton per meter), assign to selected beams, assign, yes. Then one more 17 kilonewton per meter, assign to selected beams, assign, yes. Then here 18 kilonewton per meter, selecting these beams, assign to selected beams, assign, Yes. Okay. So in this way the vertical force load is get added, and if you want this will be the lateral forces get added, right? Now let's add one more load case detail as combination of lateral load plus vertical load. Let's say the factor as 1 only, lateral load 1, then vertical force load 1, add over here. Now let's take one more load combination as lateral load plus 1.5 times of vertical load. So here I am considering lateral load factor of say 1, then 1.5 as a factor, and applied to vertical force. Okay, add over here, then close. Now next go in the analysis and print, select over here all, add, close, perform the analysis, select the structure, assign. Okay, now run analysis, save. Okay, 0 errors, 0 warning, done. Can go in the post processing mode. Okay, apply, okay. Now here I am considering the first case of lateral force and taking this shear force diagram. Now in case of lateral forces there is only lateral force acting at the floor levels or joints. So this is a shear force diagram in that case, and this will be the bending moment diagram due to the lateral forces, right? Now next, if I am selecting here the vertical forces, so this is a bending moment diagram in case of these vertical forces. Now here if I am selecting this lateral plus vertical, so this will be the bending moment diagram due to this lateral plus vertical forces. Similarly, whatever the fourth combination I have selected, lateral plus 1.5 times of vertical force, that will be also displayed over here. Similarly, if you want you can check the shear force and bending moment diagram for different combinations, that is lateral plus vertical, only for lateral, only for vertical, then lateral plus vertical, lateral plus 1.5 times of vertical. Okay, similarly you can go for the reactions also over here, that is xy directions or reactions at x and y direction, as it is a fixed support, and again the moment values. If you select any particular beam over here and you select over here, then you will get the values of reactions for that beam. Then if you select another beam, then here beam number 5. Next if I am selecting this beam, then the beam number 21. So all the reactions and movement for that beam, that will be get highlighted over here. If you select the graph also, again you can change over here the combinations of forces. So this will be the combination of lateral force, and these are the bending moment shear force diagram for this beam. I am selecting the another one. Further if you go for the vertical forces, then these are the bending moment and shear force diagram for the vertical forces. So likewise everything that will be get available over here, whatever you want in that one, that you can check by considering the different options. Then can go here in beam. Okay, can check over here lateral plus vertical load, what are the bending moment and shear force diagram shapes and all that. Can go in again the modeling mode. Again if you want you can plot the reports also for different options. You can check, take out any 2-3 type of reports. In first one the analysis because of lateral only, in the second one the analysis because of vertical loading only, or in the combination of lateral plus vertical. Whenever we are considering the earthquake load and wind load, so without consideration also you can plot the different shear force and bending moment diagram, and with consideration also we can plot the shear force and bending moment diagrams for this. Okay, similarly you can add n number of bays for this beam over here. For example, if I want to repeat over here the beam, so I am selecting this beam, go in the translational repeat mode, y direction, taking one more step of 5, link the step. Okay, so here one more bay will be get added over here. But now if you check in the load definition, so here that load is get copied over here. Similarly, if you check the vertical forces also, so that load is get copied for the upper floors. You can add any number of floors, n number of floors, by using this translational repeat on the upper floors, or you can also add the number of bays on this side also. For example, if I am selecting this and considering the translational repeat in x direction, taking one step of 5, then okay, so one more bay will be get added over here. You can delete this bay, right? So you can add n number of floors and all that in the horizontal as well as in the vertical direction for this. Okay, and do the analysis for the same over here, right? You can go for the general and all, right? So in this way you can practice for different trial and error versions. Because see, though you are not doing the practice by just looking all these videos, you will not understand the things. Once you start practicing, you will came to know where you are lagging or where you are making the mistakes, and that will be rectified and get removed. And as you make the practice, you will be get perfect in applying or assigning any different conditions or for the analysis purpose. Okay, so do the practice of solving more and more trial and error versions in case of this analysis of beams or analysis of frame structures. Now in the upcoming videos we are going to discuss the analysis of trusses, and at the last we are going to discuss the analysis and design of one complete G+3 RCC building. Okay, till that you do the practice and solve more number of problems. Okay, thank you.